Hi everybody. Today we're looking at a Criterion B investigation. I think primarily this video is done so as to help the students or pupils to build some confidence in dealing with Criterion B investigation. This has always been historically one of the harder investigation if you do the MYP, um, just because looking at patterns, making general rules, formulating those general rules, and even having to verify them can be quite a challenge for those who are not very accustomed dealing with patterns in on the whole. Okay, so I just want to go through one little investigation, and hopefully this just gives you a bit of a nice little refresher on some of the things that we usually do in Criterion B tasks. Okay, so let's just really get down to business. Today we're looking at some patterns that relate to areas and perimeters. Um, and of course, there are um, hundreds of patterns that relate to areas and perimeter, but I'm just going to show you one investigation which I found it very exciting and interesting. And hopefully this will give you some insights as well. And so today we're going to be looking at a Criterion B task with let's start off with by looking at some of the common number patterns that we usually see in different types of numbers. And I think specifically the most common ones that we usually see are square numbers, cube numbers, and triangular numbers. So just to kind of recap what a square number is, if you look at the first row of dots here, and if you count the total number of dots, and why is it obviously called a square number? Because it creates like a little square here. Okay, so again, if you count the number of dots in pattern 1, pattern number 2, all the way up to 5, so I'm going to really quickly put those numbers in. So it's 1, 4, 9, 16, and 25. So pretty straightforward for square numbers. Now cube number belongs to this second row of cubes, and we know that the special feature of a cube is that the length, the width, and the height are always the same. So if we start off with a 1, um, the first pattern number when you have each length, width, and the height to be 1 centimeters or 1 unit, all right, we don't necessarily have to call this centimeters. And if you just multiply the volume, you're just going to take 1 multiplied by 1 multiplied by 1. So that gives me 1. The next one can have 2 multiplied by 2. That gives me 8. 3 multiplied by 3 multiplied by 3. 4 multiplied by 4 multiplied by 4. And finally 5 multiplied by 5 multiplied by 5. So that gives me 125 for the cube number. And triangular numbers work very similar to the square numbers. Just add up the number of dots that you see. So you're going to get 1, 3, 6. Oh, sorry, 1, 3, 6. Yes, that's right. 10, and this will be 15. Okay. So these are the very common patterns that we usually see with numbers. But I mean, it's not an exhaustive list, but these are some of the very common ones that I would say, particularly in the MYP 1, these are things that you should absolutely know it at this stage. Okay. Now, so we're going to look at one of our main tasks for today is to look at how the length and the width of a rectangle relates to the scale factor, and how that relates to the perimeter as well when we change the scale factor. Okay, so what does scale factor basically mean in the first place? It's basically enlarging the rectangle by a certain size. Okay, now when I say a scale factor of 2, which means that we're going to be multiplying the original rectangle for both the length and the width by 2 times, or basically doubling the dimensions of the rectangle. When the scale factor is 3, we're going to triple the original length and the original width of the rectangle. Okay, so again, if we do the scale factor of 1, which is literally the first rectangle, which is 2 centimeters by 1 centimeter. So if you add up the perimeter, we can just take 2 plus 2 plus 1 plus 1, which is basically adding the dimensions of the rectangle. And for scale factor 2, we can do 4 plus 2 plus, sorry, so I'll put 4 plus 4 plus 2 plus 2. And the next one will be 6 plus 6 plus 3 plus 3. The fourth one is just 8 plus 8 plus 4 plus 4. And finally, the last one is 10 plus 10 plus 5 plus 5, which is basically adding everything up by the size of the rectangle. So you're going to get the perimeter to be 6, 12, 18, 24, and 30. Very nice perimeters. It seems like the perimeter is always going up by 6 each time when the scale factor goes up by 1. So again, one of the common questions that usually will be asked in the criterion B is write down the pattern, all right, from what you have just done earlier. So I think we can just simply, confidently, we can write this: the perimeter goes up by 6 each time when the scale factor goes up by 1. Okay, so I think that's a very common pattern. Some of you might even write this, that the perimeter are all even numbers. Now, I'm not a big fan of this answer because the question is asking how the perimeter has changed. So I think to really answer the question, this should be a better answer. But is there technically anything wrong with the pattern? There is nothing wrong with saying that the perimeter are all even numbers when the scale factor goes up by 1, but it doesn't really tell me how the perimeter changes. So I think we need to be very cautious when you write the patterns. Make sure you read the question carefully as well. Okay, so I'm just going to write this. I'm not a big fan of this. Okay, because it doesn't really answer the question, but technically it is still a pattern. Okay. Now it says use your pattern to predict what the perimeter will be like for the next two rectangles. So we know that if it goes up by 6 each time, so the next one should be adding 6 to 30. Okay, so this should be 36 and the last one should be 42. Okay, so pretty straightforward. And it says write down a rule how you would use the scale factor to calculate the perimeter. Okay, so I'm just going to divert you back to this little table that we have here. Okay, one thing you probably would have realized, okay, I'm just going to use my pen here as well, is that if you look at the scale factor, which is 1, I'm trying to find out if there is any way I can get the scale factor to obtain the perimeter that I have by using the scale factor given to me. Like, how am I going to use 2 to get to 12? How do I get 3 to get to 18? Now remember, we found earlier that the pattern was going up by 6, so somehow that 6 should somewhat intuitively be embedded into your rule. Okay, so I'm going to try several ways to do this now, because we know that you are multiplying your original length and you multiply your original width to get to the enlarged rectangle, so it should somewhat involve multiplication as well. So if we put all this together, maybe we could have just found a way to find a rule here. So what I'll do is I'm going to experiment. If I'm going to take the scale factor of 1, I'm going to try multiplying this by 6, because we know that it's going to involve multiplication and it's going to involve 6. Now if I take 1 times 6, does that give me 6? Looking good so far. But we need to try that if it actually works for the rest as well. If I take 2 times 6, does it give me 12? So far so good. If I take 3 times 6, does that give me 18? Looks good. If I take this times 6, does it give me 24? Looking good as well. And finally, if I take this to be multiplied by 6, does it give me 30? Absolutely. Okay, so which means if it's consistent across all the examples given to you, all right, I think generally what we could do now is to write a general rule. Okay, let me just go back to this, and let me enlarge this, and it says write down a rule. Okay, so there are 2 ways to go about writing a rule. I think if you're in the lower years, if you're in the MYP 1 or MYP 2, I think generally you should be quite comfortable writing this in words. You can say that the perimeter is basically multiplying the scale factor by, so let me just go back to this again. If I take the scale factor and I multiply by 6, that's going to give me the perimeter. Okay, so I'm just going to write this by 6. Okay, now this is writing in words. Now if you want to write it as an equation, you can absolutely do that. You can call the perimeter to be P, and you can call the scale factor to be any other variable. Alright, I'm just going to call it this SA. Alright, just to make it simpler for us. So I can just simply say that perimeter And again, we have to observe some of the basic rules of algebra, which is P equal to 6 multiplied by SA. So I can just put 6 SA. Okay, we don't really need to put the multiplication sign when it comes to writing an algebraic equation, because that's pretty much known as a multiplication. When you combine a number, when you multiply a number to a variable, there is no need for you to put the multiplication sign. So you can put P equal to 6 SA. That would be good enough as well. Okay, so whichever is comfortable with you. Writing in words, absolutely fine. Okay, now the next part of the in the criterion B task is, after you've written the general rule, we need to verify it. Now let's talk about what verify is. Okay, let's define what even verify even means in the first place. Now verify is to show that your general rule works with examples. That's it. Okay, technically, if you do in the MYPE assessment, technically you only need to do one example. That would be fine. If you want to do it 2 examples, that's absolutely fine as well. Okay, but generally what you need to do is to show with examples. Now there is a little condition here. Now when we refer to examples, all right, examples here refer to the ones which are not given to you in the investigation. Okay, so if we go back to the original investigation given to you, it gives you from scale factor 1 to 5. You can't use any of them. You have to use a different one. So you want to use the next one instead, which is going to be scale factor 6, because that's the really obvious one. Do you want to do scale factor of 100? I think it's fine, but you don't want to deal with large numbers. So I don't really encourage you to do scale factor of 100. Okay, so I think in this case, technically you want to use the one that's not given to the investigation, and you want to use the one in the next pattern number. I think that's what I would encourage for all investigation when it comes to criterion B. Okay, so remember the general rule that we had earlier was the perimeter was 6 multiplied by the scale factor, isn't it? So what I'm going to do now is we're going to find out when the scale factor is 6. What is the perimeter? So we're going to do 6 multiplied by 6. That gives me 36. Now, so far so good. We have just found that from the general rule, the perimeter is actually going to be 36. But how do we even know that the rule that we came up with was even a valid one? Was it by chance? Or do we still need to show that this 36 can be calculated from a different way, so that we can actually validate the result that the general rule actually works? So what I would really suggest as well when it comes to verifying is, besides using the general rule, you should really try to use a little diagram, draw a diagram, okay, to show that it works. Now, originally when you started off with the rectangle when the scale factor 1, this was 2 and this was 1. Okay, this was when the scale factor was 1. This was the original rectangle. Now, if you chose scale factor of 6, that means I'm going to basically multiply each of the dimensions by 6. So this actually is going to give me 12, because 2 times 6 gives me 12. And if I take 1 times 6, that's going to give me 6. So this is actually how the rectangle looks like when it's a scale factor of 6. And of course, we can just calculate the perimeter here by adding all the numbers up, and that should also give me 36. This number should match with this number. If you could match both of these numbers, your rule is verified. Okay, so this is what verify actually means when it comes to a criterion B assessment, and we are expected to look at how you use the general rule to come up with the perimeter, and how you basically draw a diagram to show that the perimeter matches with the one that comes with the general rule. Okay, so that's what verify is really all about. And I would also recommend that once you have done these 2 steps, can you please also make sure you write a final statement and say that the rule is verified. Okay, so rule is verified from these 2 methods. Okay, I think this would just generally be a very good way to conclude a very nice verification process. Okay, all right, so let's move on to the next one. Okay, now we're going to start looking at a little more complex pattern. I think generally why is it called a complex pattern is because nothing is really given to you in the table now, but when you did the earlier one, everything was all being done for you. All you really need to do is just to fill in the table. So at Criterion B level, we are always expected to do one investigation independently, while the other investigation, which is the one that you did earlier, is more like a guided investigation. All right, which probably will lead all the way, which will probably give you like grade all the way to grade 5 to grade 6, if you have done it all correctly. But looking at level 7 and 8, we need to start looking at investigating this in a very similar fashion, but a little more independent task that you need to go ahead doing this investigation as well. Okay, so in this case, we're looking at connects the scale factor with the area, and we need to find a rule. So we're going to start do the same thing. We're going to call this the scale factor, and we're going to call this the area. Okay, so I got 1 2 3 4 5 all given to you. We're going to work out the area of each rectangle, so that's going to give me 2 8 18 32 and 50. Okay, so these are the areas of the 5 rectangles here. So I think firstly, let's try to find out what is the rule here. Again, the rule needs to involve the scale factor and the area. This is a bit different because I'll show it to you. I'm going to write it here. Now, to get from 1 to 2, again, we know that multiplication will be involved. So I'm going to try to experiment again. I know that if I take the scale factor, which is 1, and to get the area of a 2, I probably need to multiply the 1 by 2 just to give me 2. Now the scale factor, which is 2 for the next one, to get 8, I need to multiply this by 4. Okay, it's quite different from the original pattern because you're not really multiplying by the same number, because the first number was 2, the second number was 4. But let's try the next one. 3 multiplied by 6 actually gives me 18. Okay, we'll look at the next one as well. The more we see, the better it should get. 4 times 8, that gives me 32, isn't it? Okay, and finally we got 5 times 10, that gives me 50. Okay, now I'm not sure if you may have spotted something, is that the numbers which is 2, 4, 6, 8, and 10, alright, even though they are even numbers, but again, writing as an even number is really not going to be very helpful for us to find the area. If I want to find the scale factor of 26, I wouldn't even know what this number is going to be, because I don't want to write all the numbers up to scale factor 26. I want to be able to see the rule, and I should be able to find the area so quickly and so efficiently as well. So I just want to be able to find another pattern that's really going to help us to find the area given the scale factor. Now, I'm not sure you have observed this. This number seems to be the double of this number here. You realize this was 1, then this was double of 1, that gives me 2. This was 2, and to get a 4 here, I'm actually doubling 2 to get 4. And to get a 3, this was started off with a 3. If I double 3, I'm actually going to get 6. So it seems like when I want to find the area, I could actually now write a rule. I'm actually taking literally the scale factor multiply by this number is actually taking the scale factor, so I'm going to times the scale factor again, and I'm going to multiply this by 2. Alright, because the second number is always taking the scale factor, and you multiply this by 2. And this actually works. But we need to again show it by verifying and testing, okay? Now, verifying is the same thing again. We're going to use the other rectangle, the next rectangle, which is the 6th rectangle, to verify it. But before we do that, I want to show you that we can actually do a test as well. Now, test and verifying means different things. Testing basically means that you should be using the diagrams given to you to test the general rule. Okay, so I'll just show you really quickly how we test it. Okay, so again, another big command term that you see in Criterion B, which is testing a general rule. Now, again, you can have the choice of choosing between 1 to 5. I'm just going to choose like 3 in this case, okay? So if when your scale factor is 3, I can say that test when your area will be equal to 3 times 3 times 2, okay? And this, when you multiply all these numbers, it should give me 18. And this number should also match with this number here, okay? And that means that the testing has been done correctly. All right. There isn't really need to you to draw the diagram because the diagram has already been drawn to you for you, okay? Now, that brings me to the next part, which is just simply verifying the general rule, okay? So verifying, again, it's just basically repeating the same procedure that we did earlier. I'll draw the 6 rectangle here. This obviously would be just be 12, and this would be 6, okay? Now, if you multiply the area, we know that the area in this case would just be 12 times 6, okay? So 12 times 6, this would be 72. Then again, if we use the general rule that we found earlier, which is scale factor times 2. So with the general rule, I'm just going to do equal to 6 multiply by 6 multiply by 2. Okay? Again, if you multiply these 3 numbers here, you should also get 72 in this case. Look at these 2 numbers. They match, isn't it? So that means your verification would have worked as well in this case. So guys, I hope this gives you a nice little wrap up to what the Criterion B investigation always look like. Some of the command terms that we use generally will be verify and testing. When it comes to writing a general rule, again, you are not bounded by the fact that it has to be written in an algebraic equation. It could also be written in words as well. Alright, so I hope this video helps. I hope you like this video. If you like it, please subscribe to my channel, like the video, and if there is anything else I could help you, particularly about MYP, whether it's an investigation or is it any other criteria that you may be struggling with, just write me a message. Just drop me a message. And I will I read them, I read those messages, and I'll make those videos according to the demand as well. Alright, so till then, and I'll see you the next time round. Take care.